Good morning. Sorry I can't be there today and probably not tomorrow. We'll see. Anyway, we are looking at two-dimensional figures. Okay, these are flat shapes that we're looking at. It's a lot of vocab, so have your paper and pens ready. And yeah, not a whole lot of numbers today. Sorry. Okay, one of the words that we're looking at is a tessellation. So a tessellation covers an area with a pattern of one or more geometric shapes so that there are no overlaps or gaps. So we'll go into tessellations a little bit more toward the end of the book, but a tessellation we see often things that have shapes with no gaps like tile, flooring tile, or backsplash. It's very important that these shapes line up well together. So, if they have a gap on it, it's not going to look good. Curve. Excuse me. A curve is a continuous set of points. If you need more time to write, please pause the video. It will also be on Teams, so you can look through it again. And yeah, if your book's open, all of the definitions should be in your book as well. A closed curve ends at the same point that it begins, which makes sense because it's closed. A simple curve does not cross its own path. Okay, so I'm going to go ahead and draw this. Okay, this is not a simple curve because it crossed its own path. It is closed because I started at the same point that I began, but it's not simple. All right, the first shape that we're looking at is a circle. Hopefully you remember what a circle is. It's a set of all points in a plane, a given distance from a given point, the circle center. So all of these have the same distance from the outside to the inside of the center. So the segment from the center to a point on the circle is called the radius. And hopefully you guys know this already. If you know this, you don't have to write down every little word. Okay, you can draw a circle and label it if you want, but anyway, you don't need all these little details. The interior of a circle is the set of all planar points whose distance from the center is less than the radius length. So that whole blue shaded area, like the longest description to just it's the inside part of the circle, the part that you would color in. The exterior, okay, that's the outside, is a set of all planar points whose distance from the center is greater than the radius length. So whoops, that was not a good underline. But the whole, that's not going to show up well, outside of the circle. Here we go. Oops, that was supposed to say outside. But this whole area, that's the exterior of the circle. Any simple closed curve divides a plane into three disjoint sets. There's that beautiful term again, three disjoint sets. The curve itself, its interior, and its exterior. So I'm going to make my circle. Okay, that's not a circle. Okay, I don't know what happened and I can't go back. I'm sorry. Let's see if I can draw it here. So that's the circle part. And then we have the interior, which I'm going to say is blue. And I'm going to try there. And then we have the exterior. So those are the three disjoint sets. Okay, a region is the union of a simple closed curve and its interior. The curve is the region's boundary. Okay, they have that awesome example of that jelly bean looking curve. Okay. And again, this isn't something that we haven't heard of before. I mean, if you look at like property lines of houses or whatever, you know, it's like, or you know what, a house, that's great, because the house includes the walls, right? It includes that boundary and the inside of the house. You'd call the whole thing your house. So that's your region. A set is convex if every segment with endpoints in the set is completely contained by the set. In a concave set, a segment can be drawn whose endpoints are in the set, but the segment is not completely contained by the set. So this looks like craziness. Okay, not great definitions as well. But we're going to look at concave and convex shapes very soon. Okay, a polygon is a simple closed curve that consists only of segments. Okay, so it's not round, it's segments. Each segment is a side of the polygon, and each endpoint of a side is a vertex. Okay, so I'm going to try to draw a polygon. This is obviously not a regular polygon, meaning the sides are not congruent, but I have a pentagon here, and I have a vertex right here, and then here's another vertex. I'm going to call these A and B. You guys already know I can't draw on this thing. And this right here is my side. And I'm going to call that side segment AB. Okay, so we're going to look at these shapes and determine if it's a polygon. Okay, this one right here, is this a polygon? Well, I kind of just drew that so you know that yes, it is a polygon. How about the second one right here? This one is not a polygon because of this curved side. Okay, is this star a polygon? Yeah, I think that could be a polygon. And then this last one right here, it's not closed. If maybe there was something right here, then it could be a polygon, but there isn't, so it's not. An equilateral polygon is a polygon in which all the sides have the same length. So I mentioned yesterday the equilateral triangle. That meant all of the sides of that triangle were the same length. And we have that for obviously other polygons, the pentagon and octagon and other polygons that we have. I can never say this word, but you can read it. An equangular, yeah, that's really bad, is a polygon in which all of the angles have the same degree measure. Okay, all of the angles are congruent. I think a good example of this would be a square. There we go. All of the angles are equal and all of the sides are equal too. Bonus. A regular polygon is when it has equal sides and equal angles. So when I was trying to draw that pentagon first and I said it was not regular, this is what I meant. It does not have equal sides or equal angles when I was drawing it anyway. So your book has this beautiful list of classifying polygons and what to call a polygon depending on what, how many sides it has. So you can, you don't have to copy all of this down. This right here, I learned these when David was 2 because there was a song on YouTube that he liked to watch about shapes. And it talked about a dodecagon. And I was like, what in the world is a dodecagon? And now we know. It's a 12-sided polygon. And then dodeca, I mean, if you guys know your prefixes, we know that this is 10, this is 9, and this is 8, 7, 6, 5, and quad is 4. Okay, the ones that you may not know was the hend and the dodecagon. All right, classify each polygon by its number of sides and then state whether it forms a concave or convex region and whether it's equilateral, equiangular, I'm never going to say that, regular, or none of these. Okay, so I can already see right here that I have, let's see if I can get the laser thing. Okay, that I have these 4 angles that are congruent, but not those. These are not congruent. So even though the sides are congruent, the angles are not. So this is not a regular polygon. It's equilateral. Okay, I have the tick marks on all of them, on all of the sides, but it's not, right, it's not regular. Concave or convex. So concave is when the polygon dips in, just like this. So, and convex is when it pokes out. So this is a concave polygon because it dips in like that. Let's look at this guy right here. We have, okay, that's one side, 2 sides, 3. Okay, so this has no congruent sides. It also has no congruent angles. So it's not regular, it's not equilateral. I'm not saying the other word. It's a convex region. All of the vertices are pointing out. But yeah, it's none of the other things. Okay. I guess we could call it a quadrilateral. It just doesn't have any of the qualities that we're looking for anyway. Let's see. I have another shape here with 1, 2, 3, 4, 5, 6, 7, 8. Hopefully I counted that right. Looks like it's 8 congruent sides. And all of the angles, interior angles, have the same one arc, which means all of their angles are congruent. So that if it has congruent sides and congruent angles, it means that it is a regular polygon. And it's an octagon, since there are 8 sides. That was an easy one. Alright, so polygons are named by listing the vertices in consecutive order. A diagonal of a polygon excuse me, is any segment that connects 2 non-consecutive vertices. Let's see if I can draw an example out for you, or try to. Okay, so if I have a polygon, a square, okay, this is A, B, C, D. Okay, I cannot call this square ACBD. Okay, it has to go in an order. Okay, so we would go in this rotation. You can go in the other way as well, but I think this, especially since that's in alphabetical order, it kind of helps to go that direction. And then while we're at it, I'll go ahead and draw a diagonal. Oh, that was terrible. Okay, we're going to pretend it connected this vertex with the opposite vertex. They are not consecutive. Okay, each vertex of a triangle, and therefore each angle, has a corresponding opposite side. Okay, what that means is this angle, I'm going to look at B right now, is looking at an opposite side, right? This side is directly across from it. And because it's the angle that is looking at that side, I'm going to call this lowercase b. And if I were to look at A, okay, I'm over here now. What side is it across from it directly? This guy. So this would be A. We're going to go one more. So I'm at C, looking across. This is side C. So that's the corresponding opposite side. The distance around a closed curve is called its perimeter. To find the perimeter of a polygon, simply add the length of its sides. So that's something that we should all know. Okay, the perimeter is the outside. Please do not get it confused with the area. The area includes the region. The perimeter is just the outside. The perimeter of a regular polygon with sides of length s can be found using this formula, okay? So n represents the number of sides, and s is the length of the side. I cannot write all of this out. So now we're going to be looking at components of a circle. So we already looked at the circle and the radius of the circle, but now we're going to look at the chord of a circle. So that's any segment whose endpoints are on the circle. In this case, BC would be a good example of a chord. So I'm going to go ahead and highlight that. BC. So the two endpoints are on the circle. It is not necessarily going through the center. Technically, the diameter is also a chord because the endpoints are on the center. I'm sorry, the endpoints are on each, like, they're on the circle. They're on the perimeter of the circle. Speaking of diameter, that's the chord that contains the circle center. I'm going to go ahead and highlight that there. So the chord DA. Then we have one more. Whew, sorry. An arc is a curve that is a subset of a circle. So remember, this word subset means a part of. A part of. And so they've actually already highlighted it in red. They were really creative and used the same picture for all of the definitions. But that highlighted part in red, that's the arc AE. And I'm going to put an arc over it because it is not a line segment. So some things that should also be reviewed is that we know that the diameter is twice the length of the radius. So here's my circle, here's my radius, and my diameter is going to be twice the length of, wow, that's a really bad circle. Sorry. But yeah. The distance around the circle is called its circumference. We'll look at the circumference of a circle soon. So the ratio of a circle circumference to its diameter is always the same. And so this is actually really, really neat because you can do this at home if you want and try it out. But measure something circular, just measure the outside of it, and then measure the diameter of the circle. If you make a ratio, so ratio will have your division sign. Okay, if we did the ratio of the circumference to the diameter, you will get the same number every time. And that special, amazing number that is also delicious is pi. So for the most part, we simplify it to that, 3.14. You can also express it as a reduced fraction of 22 over 7. So that part's not used very much, but we usually use the 3.14. The circumference of a circle with diameter, d, or the radius can be found using either one of these formulas. So if you're given the diameter, you can use this first one that I am boxing up. And if you are given the radius, you can do this. Okay, so it's 2 times the radius times pi. It just looks prettier when you put the 2 in front of the pi. Okay, find the missing measure. So they gave me the circumference of 10 centimeters, and they want to know what is r. So we're just going to use that circumference formula that we just looked at, and we're going to plug in the things that we know. We know what c is, so we're going to substitute that. And now we have the pleasure of solving for r. Remember with math that we're going to see this a lot in geometry. We're going to deal with pi a lot. So you're going to treat pi like you would any constant, and you're going to divide both sides by 2 pi. Okay, so this cancels here, and I have r is equal to 10 centimeters over 2 pi, and if you put that into a calculator, it would be approximately 1.59 centimeters. Okay, so we're finding the missing measure of an example that I cannot see right now. Okay, well, hopefully your book has like a picture or something. The circumference of a water tower that measures 60 feet across. Okay, if it measures 60 feet across, is this a water tower? Does this look, okay, maybe not. Wow. Okay, so it measures 60 feet. So that's the diameter. So we're going to be using the other formula. The circumference is equal to pi times the diameter. And we need to find the circumference. So we don't know what that is, but we do know what this is, so we're going to substitute. And 60 times pi. So honestly, you can leave it like this. When it comes to like homework or anything like that, you can leave it as 60 pi. That is fine. If you have a calculator on you, you can put it in your calculator and give me the decimal, but I will accept 60 pi. To me, that is simplified. Okay, so that's it for today. You have your classwork to do, so hopefully you can finish that in class, and I will see you guys another time.